guys, what's up? So I want to do something for you this week, something kind of special. We're going to talk about something called, well, I did a demo for you. So I did sodium metal and water. Okay. And what I've done is just put solid sodium metal just into water. Okay. And this is perfect for us right now because we've been talking about the periodic table and activity series and reactivities of metals and valence electrons and all that stuff, right? So if we remember that sodium has that outer valence shell, right, with one single electron in it. Okay, it's N equals 3 shell, I believe. Okay, and sodium wants really badly to donate that electron somehow or give it up so that it can drop down to a noble gas configuration at N equals 2 with a full octet. 1, 2, 3, 4, 5, 6, 7, 8. Okay, and so there's a lot of that chemistry going on, and I want you to see. I mean, we talk about how reactive sodium is and stuff, and we talk about how it really wants to get rid of that electron. But what does that mean in real life? Okay, and so this is a really cool demo for you to get to see what that looks like, what's going on there. Okay, so I'm going to do it in the video, and I'm going to film it two ways. I'm going to film it once with just like a regular camera, and I'm going to film it at the same time with a special camera I have that films at 1,000 frames per second. So I'll slow the reaction way, way, way down, and you can see kind of what's happening there, okay? But essentially what's happening, and I'm going to write the rest of this equation, is that the sodium is turning into these sodium cations, right? Because once it loses this electron, right, it becomes this noble gas configuration sodium cation, right? So we're making sodium cations, and that makes sense, right? Because it's giving up that electron. And it's making these hydroxide anions out of water, okay? So it's pulling, if we look at water, right? It's actually ripping one of these hydrogens off the water molecule, okay? So it's kind of, it's the reactions, sodium wants to give up this electron it has so badly that's kind of just pushing it into here, into this bond, and the bond breaks and gives one electron to the oxygen, one electron to hydrogen, and we end up with this kind of sodium plus, right, which we already talked about. We end up with this, we end up with this, what's called a hydrogen radical. It's a hydrogen with a single electron on it. Okay, so now this hydrogen really badly wants to complete its duet, right? Okay, and so, and then the other thing we end up with is this OH, and it gets one electron from this bond here, right, that's split, and one electron that sodium gave it. So now oxygen has this octet here, but it's also got a minus charge, so it's become an anion. Okay, and we know from experience that cations and anions are electrostatically attracted to each other, right? Okay, and as this reaction continues to happen, we're going to make more of these hydrogen radicals, and they can combine together to give these hydrogen H2, which is just hydrogen gas. Okay, so the other product of this reaction is H2 as a gas. Okay, and this is a perfect example of what we're looking at. Just this, what we'll look at this next week is called chemical equations, where we talk about the reactants. Okay, and then this arrow indicates that some kind of change has happened. Some kind of chemistry has happened. Okay, it's not always a chemical change. You can actually use this to indicate physical changes, but usually it's chemical. Okay, and then this side we call the products. Okay, this is what's produced from the reaction. Okay, and so we know that we need to get two hydrogens to make one hydrogen gas. So it takes two sodiums, okay, to break up two water molecules to make 2 sodiums and, oh, I already wrote that in, but 2 hydroxides, okay? And each of those, and that balances out to make H2, okay? So if we were to look at this, add these up, we would have 2 sodiums on this side, we have 2 waters, okay? We have 2 sodiums here, okay? And just to show you, okay, OH, right? That's just H2O, okay? So two parts of this water go here, and the 2 hydrogens go here, okay? And that's important because nothing is created or destroyed in chemical reactions. They're just changed, okay? So we have to have the same number of things on each side, okay? And if we break this up by atoms, we have 2 sodiums, we have 2 times 2, so we have 4 hydrogens, and we have 2 oxygens on this side, okay? On this side, we have 2 sodiums, okay? We have our 2 oxygens here. We have our 4 hydrogens here, okay? And that should be an O, okay? So everything is what's called balanced, okay? And that's important. That's important when we're doing this. All right, so I wanted to show you kind of just the simple chemistry of this. And actually, it's a lot more complicated than that. So this is kind of the simple version. There's a lot going on that we're just starting to understand. There's a whole quantum mechanical side to this. And it turns out when you drop the sodium metal into the water, it actually creates something called solvated electrons. So it wants to lose those electrons so badly that it shoots these electrons out into water. And they stay as free electrons for a little while, which is really interesting, for a very brief time in water. If you do the same reaction in ammonia, they can be stable for days. And they make this bright blue color. Solvated electrons turn the water really bright blue. And I tried to catch that with my camera, but it's just not high quality enough and it's not fast enough. But I'll find some pictures and videos for you of solvated electrons because it's really interesting. Okay, another couple things you'll notice about the reaction is, of course, it's really violent and there's a lot of fire and cool explosions and stuff, right? But also, you'll notice that the sodium metal assumes a perfect sphere almost immediately. So it'll kind of like melt in the water and start spinning and rotating and turn into like a sphere. Okay, so that's something to watch for. I hope you enjoy this little demo. I'm going to try to do some more of these for you. Because we have some more interesting topics coming up. So I'll try to come up with some more interesting demos for you guys. Okay, let me know if you like this, and I'll keep doing them. All right, thanks guys, I'll see you soon. Okay, here we go. Pretty big chunk. That was it.